Supplemental math videos from Circle Christian School. The binomial theorem. It's all about Pascal and his little triangle. And although he's probably best known for the triangle and the many patterns inside, he made many mathematical accomplishments, starting from a very young age of 7. His mother died when he was 3. Father had to take care of him. Father tried to take him to school, but just saw that he was brighter than everybody else there at the school, so he decided to homeschool him. Later in life, he introduced him to a mathematical society with such greats as Fermat and Descartes. Smart cookie he was. If you want to know more about all the different patterns that can be found inside of Pascal's triangle, check them out at the website that I have up top here. But the whole thing that we use Pascal for are the coefficients of binomial powers. Basically, we're going to take a binomial, 2 terms, added, subtracted together, and power them up. Power 0, 1, 2, 3, 4, 5, as such. And each one of the coefficients, it's the coefficients that we really need here to be able to use different things that happen with binomials. So that was like one of his really greatest discoveries here is, ooh, look, a new way to go do math. Has to do with a combinatory equation of NCR, which you can actually find in your calculator. But if for any reason your calculator fails you or decides to hide under your bed and you really still have to do your math homework, the equation or the formula is n factorial over n minus r factorial times r factorial. No problem. You can do it the hard way too. In the old days, we foiled. Now welcome to the new math. We're going to do a binomial expansion. Instead of foiling, we're going to do it Pascal's way using his coefficients. So I'm going to take the binomial here. This is just an excellent example to go and use of x plus y to the 4th power. Now the first thing we need to know is that we have the 4th power. And that's going to give us our coefficients off of Pascal's triangle. Remembering that each of the terms from the previous page, we always start off with the initial term, that is with 0, and work our ways up to the 4th term, 1, 2, 3, and 4. So basically what that means is if I've got a power of 4, I've got 5 terms. If I got a power of 6, I have 7 terms, and so forth and so on. Now the first thing that goes in is the number from Pascal's triangle. So I'm just going to put the numbers in for the coefficients. You can either do the NCR thing or take a look at Pascal's triangle for most basic ones. The first one's always going to be 1, and then we move off to whatever the power is. So it's always 1 and whatever the power is. And then we work symmetrically up toward the middle and then back down toward the end. The last 2 again are just going to be opposite, very symmetrical, so we have 4 and 1. Nice little patterns. Next thing we're going to put in is our first term of the binomial. So we're going to put in all the x's first. It's a little bit of an assembly line. It's a setup, and then you just do the math. And then we're going to put the second term, which is going to be the y. Now notice the powers, which this is going to start with a power of 4, that our first term here is going to just walk down from 4, and it's going to be 4, 3, 2, 1, and 0, and then we're going to walk back up the other way, 4, 3, 2, 1, and 0, back to the first. Now, as I do the real math in this, what I always do is basically get rid of anything that results in a 1, because that's just somewhat of an identity here. So I'm going to do the first one, and that's going to give me x to the 4th power. Then I have a plus sign, and we have a 4. There's the coefficient. X to the third and y to the first. Plus sign. Coefficient, 6. We have x to the second and y to the second. Plus sign. 4. X to the first, y to the third. Plus sign. Don't need the 1. And x to the 0 power also equals 1. And so we end up with y to the 4th. Now another quick little pattern that happens inside here. Notice that when you add all the powers together here, they always equal 4 also. Cool stuff. We're going to try a little harder one now. One that has some value to the terms here. Again, we're going to put in Pascal. I'm going to look at his 5th row here, but it's not that hard to figure out. It's got symmetry happening here. Look at the guys up above. I had a 4 and a 6. Okay, good. 10. And then we just walk our way back down. Going to put in the first term, so that's 2x. So I've got a bit of an assembly line going on here. So much easier than having to go foil these. I don't foil these anymore. Kind of fun to sit there and blow away little geometry and Algebra 2 students when you go and do this, because they sit there and they foil all of it out and you're just secretly at your desk doing a little Pascal here, and they just go, "Oh my goodness, Mrs. Washington, how'd you ever do that?" I go, "It takes work." All right. So I've got the first one here, so I'm going to get rid of anything that equals 1. Remember, parentheses to the power 0 equals 1. And then we're going to do the power thing, because that's what happens with order of operations. 2 to the 5th power is 32, and x to the 5th power. Very good. All right. So now I've got a plus sign. And we're going to look at the next one. Be real careful, because I know you're looking at this and going, it equals 1, but no, at last it has a negative, so it does not. Ooh, I just noticed I put the 4 in the wrong place. Okay, well, we'll hide it. How about that? Since this doesn't erase things. All right, so we're going to go back. There we go. And we're going to do things with the power first before we do any multiplication. So I have a 4 here. So 2 to the power of 4 is 16. And 16x to the 4th power times a negative 1 is going to give me a negative 16. Negative 16 times a 5 is a negative 80. And x to the 4th power. Okay, so I'm going to kind of put that in parentheses because I got a negative going on here. Good, going to move on. And let's see, same thing. I'm going to work with some power stuff first before I go on. So we have 2 to the 3rd power is 8, and x to the 3rd. Any number squared gives me a positive number, so that does equal 1, so it can disappear. So I have 8x, did I say squared? I'm sorry, I meant cubed. And so 8 times the 10 is 80, and he's positive. X to the 3rd. Cool. Going to bring down my little plus sign again. Going to go to the next guy. So we have 2 to the 2nd power, so we have 4x squared. This is going to make it a negative, so negative 4x squared times the 10 is a negative 40x squared. Okay, let's see, that's going to equal 1. Even powers means we're going to have a positive number. So we have 2x times the 5, and so we get a positive 10x. Bring down my plus sign. Let's see, that equals 1. That equals 1. However, parentheses to an odd power, and we get a negative 1. Okay, let's clean it up and start from the very beginning. So I have a 32 x to the 5th power minus 80 x to the 4th power plus 80 x to the 3rd power minus 40 x to the 2nd power plus 10x minus 1. And look what happens with the signs. Minus, plus, minus, plus. Cool. Sometimes, for better or worse, what they want us to do is just find the coefficient of a certain term. And in this case, they're asking for the 5th term of a binomial to the 10th power. So you have to kind of go, here we have 5 terms, like so. This one would be 0, 1, 2, 3, 4, with, of course, 10 being the up front here. So what we need is the 10th C of the 4 here. So 10C4. Then we're going to put in the A here, which is the 2x. And then n minus r, so 10 minus the 4. And then the B, which is 1. And the r, which is going to be the 4. Okay. Taking my handy dandy little calculator, I find that 10C4 is 210. And we're going to do 2 to the 6th power, which is 32 times 2 is 64 times 2 is 128. To the, forgot the x here, to the, there we go, to the, let's see, 128 to the 6th power. It's got to go inside the parentheses. And then we have 1 to the 4th power, which is just going to equal 1. So long. See ya. And we're going to take our magic calculator and do 210 times 128, which gives us the magical number of 26880 x to the 6th power. And there is our 5th term of that binomial. Same thing for the next one here. As to the 8th power, so we've got to find our NCR. So this is going to be 8C4. And then our term inside here, so 3A, 8 minus the 4, and then the negative 4, and the R, which is 4. And again, taking your handy dandy little calculator, you will see you get a most delectable answer of 70 times 81, a to the 4th power, times 256. Oops, forgot the 6. For a wonderfully final answer of 1451520, a to the 4th power. Wow, I bet that's a fun one to do all the way out. Okay, go out and find all the little cool triangles that you can in the world, because Pascal saw them first.